Hello everyone. As part of this video, I'll explain about the very important concept of a microservice architecture, that is service discovery. When developers start learning about microservice architecture, they first do experiment with service discovery, how exactly service discovery is, what is the internals. And if you want to learn about microservice or reactive microservice, or you are coming from a monolithic background, then this is the most important concept you should be aware of. So as part of this video, I'll cover these things. So the very first things I'll cover is what is the requirement of a service registry or a service discovery. Then we'll go into the architecture of how exactly service discovery is implemented, what are the key components of a discovery service, and then we'll look around that what are the different categories of discovery, like how the client side discovery, server side discovery works, and self registration pattern and third party registration pattern, how the registration of a client application to registry service happens. Then we'll see about Eureka, how Eureka does it, and why we go with Eureka rather than going with Zookeeper or any other kind of tools which are also capable of doing your discovery service. So let's start. The very first thing I'll explain is the importance of a discovery service or registry service. So let's start with the requirements. Say that we have a UI application, client application, which is kind of any JavaScript or Angular based application. It want to have an interaction with backend services, which is a Java service or any other Python service or different kind of REST service can be there. So UI application want to have an interaction with user service and book service. This is fine till now if we have only a single server of user service or a single server of book service. Directly these IP address in a very beginning stage can be added as direct dependency into the UI client application. It can hard code the IP address of these application. But what happens when the load grows, when the requirement grows, the application demand grows? Then in that scenario, we need to load balance that. There is one more component in between, which I'll explain in another video. You can follow my channel. There you can see details about API gateway, what is the importance of API gateway as part of microservice architecture. But mostly the UI application interact with API gateway, which is kind of single entry point. This is just a heads up to know about API gateway. You can get more details into the video. So UI application does not directly communicate with the client services, but there will be a single entry point application will be there, which is kind of firewall for all the request and response, so that it can filter out the response and based on the categories or based on the demand. So consider these two. So either of this can be a client of our application, user service or book service. So UI application want to interact with user service and book service, but there will be one more application will be there which will act as a proxy for UI application in a microservice architecture. So UI application can hard code this IP address, or API gateway can hard code this IP address of this machine. But in case of demand increase of the application or the number of user increase, the request to the services also grows. So in that case, we need to add more user service, more book service, so that the load can be balanced, so that this application can take the load of whatever the requests are coming. So in order to do that one, we will add more number of user service, or we'll add more number of book service, so that the load will be distributed between these applications. And based on demand, we can do the uh, removal of these services or addition of these services. That is called elasticity of the cloud application, so that it can balance that based on the demand. So these application needs to have a load balancing, so that the application load will be distributed between these two applications. So there will be different concept of load balancing that also you can follow my channel and find some video on how exactly the client side load balancing is done, how exactly the server side load balancing is done. So there will be a load balancing concept which will do the load distribution between these two applications. So after that, so this demand increase, now there will be more number of services which will be required, and all this will have their own IP address and application name, or different way of communication or identification of this service will be required. So in order to manage this or maintain this, UI application has to have all this IP address hard coded. But in case if one of the service goes down, again, UI application has to be aware of that and has to remove that IP address. In order to do all those management, UI application will have a lot of burden of management of all these services. That is not a good ideal model of application design. So in order to design it properly, we'll have one more component which is called discovery service. This is again a normal REST service or a normal web application which will hold the details of all these applications. So like user service, if you have two instance of user service, under user service one database with the name column saying that user service, you can maintain the IP address 1, IP address 2, that these are the services I have. So discovery service maintain those kind of service registry. So that service registry is kind of a runtime database, in memory database, which will hold the details of user service, how many IPs are there, what is the address, is it alive or not. All these details are already stored in service registry. So that happens either at the client side, so client does it. Either the client will have the registration mechanism where at the time of start of the application client can register itself, or either in some other like orchestrator kind of architecture where the application environment itself will be aware of that new instance creation. So in this situation right now in the microservice world where we are not having any orchestrator, this will be managed by a service registry where the IP address will be registered, and based on that you can get the details. So all this load increase, now all these details will be with the registry service. So all IP address and database will be maintained inside the service registry. And with the help of this discovery service, the client can make a call to discovery service saying that I want a user service, give me a user service instance details. So API gateway will make a request only to discovery service, and discovery service inside that one it will maintain a service registry. Based on that, it will return back the IP address of all the machines, either of all the machine or only a single instance. That also depends on the strategy of the implementation of discovery service. But as part of Eureka service registry pattern, here it is implemented that it will return back all the IP address of the services available inside user service, and the client will do a load balancing, how exactly it wants to interact with which service it will choose. All this decision will be with the client. So after that, client will make a direct call to this user service once it is aware of what is the IP address. So this is the architecture of how exactly discovery service and registry service registry works, how client interacts with all the instance. Now we'll go into a little bit more details as we already discussed that service discovery. So like from moving from monolithic application where we have single noded or like a very minimal number of nodes, there it was easy to maintain all those hard coded IP address. But as the application grows, the distribution grows, the application or nodes, multiple nodes grow, there will be a requirement of another service which should manage all this service for us, and that is called a service discovery. And inside that one it will have service registry as the database. So also it provides the elasticity. Whenever you want, you can add a new machine, it will be automatically get registered into the discovery service, and you don't have to hard code all the IP address, and IP address should not be the same for all the application. It can change dynamically. So that is called as elasticity. You can add load or you can reduce load as per your demand. So after that, even if you have any resilience also is provided, if any of the service went down, that automatically based on some heartbeat mechanism. It removes those services from the service registry. So this is some internal architecture, how exactly it works. The service discovery, basically it is again a REST service, as I already told. It is a REST service which will have two different kind of API service. One is registry service, one is lookup service. Registry is for registration of the client. Lookup is for getting the details, like the client can make a lookup and it can get the details of IP address of those service. So the very first thing will happen is, like it the client application is the service. Here is the service which is a client application. Whenever this is started, this will make a registration into discovery service or the service registry. It will automatically make a registration to the service registry. After that, this will be available inside the service for lookup. So the second part will be, client will make a lookup of this service name. By using a name, client will make a lookup into the this discovery server, and it will get back the list of IP address available at the client side, and client will do the load balancing as part of Spring based or Eureka based load balancing. Client will do a load balancing. One more component is ribbon load balancing is there. You can look into my other video on ribbon. Based on that, you can work with ribbon, how exactly ribbon works and what are the internal architecture of ribbon also. So after that, the third step will be, the client will make a call to the service and then it will get the response. So this way, client makes an interaction by first looking into the service registry and then making a direct call to the service. So this is the internal architecture. So as I discussed, most of the things are listed here. It is basically a service discovery is basically an actively managed database of service instance. So all the instance details are actively managed inside database, and also there will be a continuous check whether the service is alive or not. Based on that, only those IP will be given to the client. And it provides another REST services. As based on REST services, you can make a registry or lookup call. Client can register, deregister their IP address, service ID, and name. Client can find register service detail by making a lookup. And because of more number of instance, multiple instance of a service, like we saw user service 2 instance were there, book service 3 instance were there, that provides one of the feature called high availability. So those are highly available instance. So even if one goes down, another will come back and take the responsibility. That architecture is called high availability. And two types of API is provided by the discovery server. One is for lookup, which is discovery or query service, API to look up for service instance details. Second is register or create or delete, API to register service instance. So this is like what exactly discovery server is. So we have different types of discovery also. As we already saw, what exactly discovery is. Lookup is discovery. Lookup is discovery or querying the database to get the details of IP. Then how many different way we can do the discovery, how many different way this lookup can be done. There are two different patterns are there. Client can do a direct discovery, or there can be one more server which can act as a server, which is responsible for making a discovery and giving the details. So that is server side discovery. Client side and server side discovery, two different architectures are there. So client side discovery, what happens is, client is responsible to find the location of service instance. As we saw, the API gateway client directly makes a call to the discovery server, and based on that, it gets the details of all the IP address. So client is directly making a call to service registry. You can see here below diagram, client is making a direct call to the service registry, and based on that, it is getting the details of all the service instance. So we have some benefit of client side service discovery. What are the some benefits are, like we can do a load balancing at client side, as well as we can do a caching also, registering cache of the service registry, the complete registry can be cached at the client side, so that if sometime the registries go down, service registry is not available because of some reason, in that case the client will have the knowledge of what is the service instance IP address and other details of all the services. This is the benefit of client side discovery. So after that, we'll see some of the drawbacks and benefits of using a client-side discovery. What exactly benefit is, like, we don't have to manage a central server, or there won't be any single point of failure for the discovery of all this lookup of all the services. So this is the benefit. And drawback, every client has to have the implementation of lookup. They should be aware of how to make a lookup to the discovery service, then only they can get the details of other service details. So every client has to have the implementation knowledge. So this is best fit in the scenario where you have all the application of the same tech stack. It is not good in the scenario where you have different tech stack, like one application is of Python, one application is of Java, and one without Spring, with Spring. So every client has to have the implementation of getting to the service discovery and getting the details, so that is a burden to all the client application. After that, we have a server side discovery. As I told, that there will be a server component which is kind of load balancer, which will get the details to from the service discovery or service registry, and that client will talk directly to the load balancer instead of talking directly to the service registry. So there is a third component is required. So here, a load balancer decide where which service the client can interact with. AWS Elastic Load Balancer is one of the very good example of server side load balancing. Let's see some of the benefits and drawbacks of server side discovery. So what is the benefit is, client is independent of all this lookup implementation. All the clients does not have to have the implementation. And benefit here is like, if we have multiple tech stack application, Java, Python, any UI based application, every application is independent of this implementation of lookup service. They don't have to have this implementation. But drawback is a single point of failure. Load balancer is single point of, if it goes down, you don't have any mechanism to find out where exactly the client is. Or either you can do load balancing of even the load balancer, multiple instance of the load balancer, high availability of the load balancer can be done. So drawback, as I already talked about that, like we need a third component which is a load balancer. uh, and the benefit we get is like multiple stack application is very good in that scenario. And also the service registration pattern, the registration can be done at the client side, or there can be a third party service registration, like as I told, the orchestrator, uh, like Docker Swarm or Kubernetes. They have the mechanism of registration of IP address, DNS resolution. There we don't have to go with the client has to write the logic for self registration. But without those architecture, we can go with the self registration pattern. So what happens in the self registration pattern is, client, whenever the client is bootstrapped, it has to give the details of its application, like this is the IP address, this is the service ID, and other details, so that the application can register itself. And also registration heartbeat signal sending, so that it will say that I'm alive, I'm active. So all these implementation the client has to do. And the third party registration, as I told, like orchestrator or orchestration engine, like Docker Swarm or Kubernetes, there when the application is created, or the uh, one Docker image is created, automatically that IP address is registered with the engine itself. They have the mechanism of DNS resolution by name, by IP address. You can find it all. Also, you have sandbox mode, so that you can control the visibility and expose the visibility over the network. So these are the patterns we have for registration also. So we have, what are the tools we have for service discovery? Is one of the very popular tool in the Java world or Spring Boot world is Netflix implemented Eureka Eureka service as the service discovery, or you can go with the Zookeeper also, which is again one of the very popular tool. But as part of, I feel like as part of discovery server, Zookeeper is not that required, as Zookeeper require lot of infrastructure and it has to be managed. It is not self-managed. You have to do a lot of management things for Zookeeper. So that's all for this video. In my next video, you'll see about like how exactly we can write a code to implement all these things. Thank you guys. Thank you for watching this video. You can subscribe to my channel to see more about microservices, Docker, functional programming.